Welcome to the Journey Shake Cam. Well, please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. In number 1, we are determining the concentration of the hydrogen or hydronium ion concentration. Specifically, it is asking for the hydronium ion. However, the hydrogen ion would be the same. We are using these 2 equations, and it's very important to understand these equations. pH is equal to the negative log of the hydrogen ion or hydronium ion concentration. We are here and we want to get here, and therefore we must undo this the logarithm. And undoing it, if you look on your calculator, you will see that above the log button there is a 10 to the x, and that's where we need to go because these numbers are exponential numbers. And therefore I put 5.25 in my calculator, I make it negative, and then I take the inverse log. Now, different calculators operate differently, and in some cases you must put the inverse log or the 10 to the x first and then put in your number. But many of the calculators you put the number in first and then you can just press shift log or inverse log or second function log and get to it. So you'll need to learn how your own calculator operates. So I make this number negative and then I press the inverse log and I come out with 5.6234 times 10 to the negative 6th. And all of these numbers we are going to take to the hundredths place. So it's going to be 5.62 times 10 to the negative 6th molar hydrogen ion concentration or hydronium. Now in the second case we are given a hydroxide ion. We're given a POH. And if I were to take the negative inverse log of this number, then I would be getting the hydroxide ion concentration, and that's not what I'm looking for. The question is asking for the hydronium ion. Therefore, I'm going to subtract this number from 14 first because the pH plus the POH is equal to 14. And I will subtract it first from 14, and therefore the pH is equal to 8.75. Now, whether I subtract it from 14 or just subtract 14 at this point, this number must be negative before I take the inverse log, before I get the 10 to the x. And when I do that, I should come out with 1.7782 times 10 to the minus 9. I'm going to take this to the hundredths place, so the 8 rounds the 7 up. 7 up. And I get 1.78 times 10 to the minus 9th molar hydronium ions. Because I can say hydrogen ions or hydronium ions, they're the same thing. That's a very important point. It's very important to look at what I'm given so I can find the right answer. And then the next one, we have a straightforward pH. So I make sure that this number is negative, and then I take the inverse log to get to the 10 to the x, and I come out with 2.2387 times 10 to the negative 10th. And therefore my answer is 2.24 times 10 to the minus 10th molar hydrogen ions. Then in the final case, again, I'm given a POH, and therefore I must subtract it from 14 first. And I'm going to get 4.35. The pH equals 4.35. Then I make sure my number is negative. I take the inverse log of it, and I get 4.4668 times 10 to the negative 5th. Notice that my exponent is normally 1 digit higher than the number I had. I round it to the hundredths place, so I get 4.47 times 10 to the negative 5th molar hydronium ions. And that's how you do number 1. In number two, we're going in the direct direction. We know that the pH equals the negative log of the hydrogen or the hydronium ion concentration. And the pOH is equal to minus the log of the hydroxide ion concentration. And the brackets always mean molarity. Now in this case, I first had the molarity of the hydrogen ion, and therefore I just put it directly into this equation, and that calls for me to just take the log of it. And when I do that, I get 5.2604. Again, I'm taking everything to the hundreds place, and it would be 5.26 is my pH. In this case, I have a hydroxide ion. So when I take the log of this number, and this number we can do in our head, 1 times 10 to the negative 9th, when I take the log of that, I'm going to get minus 9. And remember, the reason that the formula here begins with a negative is so that all of the numbers come out to be positive. And when I have a negative exponent and I take the log of it, I'm going to get a negative number. And the pH scale always has a positive number. So when I get the number 9, that is the pOH, and therefore my pOH is 9. Well, the question is asking for the pH, and therefore I know that my pH plus the pOH is equal to 14, based on the ionization constant of water. And therefore, when I subtract 9 from 14, I get my pH is equal to 5.00. It's very important to read the question and see that I'm talking here about a hydroxide ion. Now, in the case of C, I'm given a compound, and you'll notice that this is a strong base. And strong bases have 100% dissociation. Therefore, I'm going to get 0.5 molar of the sodium ions and 0.5 molar of the hydroxide ions. And therefore, when I take the log of this number, because I'm just putting it into this formula, and when I take the log of it, I get 0.3. And so my pOH is equal to 0.30. Then I subtract that from 14, and my pH is 13.70. And finally here, we have 9.47 times 10 to the negative 9th molar hydrochloric acid. Well, we know that hydrochloric acid is a strong acid. And again, it dissociates 100%. So I get the same number of the hydrogen ions here. And when I take the log of this number, I get 8.0236. And I take it to the hundredths. And that is my pH. Whenever I have hydrogen ions or a strong acid, I can go directly to my pH. If I'm given a hydroxide or a base, then I'm getting a pOH. And it's very important that we distinguish between those two types of problems. And that's a little bit of review from last time. And tonight's assignment, you get to review a little bit more. I find students have some difficulty going back and forth, so we'll do a little practice. You'll name a few little compounds, look over your Penguin Revisited, and I can't wait to see you tomorrow. Bye.